Question 3 says, given two straight lines with the equations shown here, equation 1 and 2, on the graph on the right here, where each unit is 1 centimeter, for part 1, it wants us to find the coordinates of point P, the intersection of lines 1 and 2. So we can look at the graph we've been given here, and we can see point P is right there. One way to approach this problem is to look at point P and figure out what the coordinates are from the graph. So we can see here that we're at x equals -2, y equals +2 for point P. But since that's just from looking at the graph, and sometimes you could think that a point lies exactly at 2, but it's really a little bit off. One way to check this is to plug in these values into the equations we've been given and see if this works out, because this point P should be falling on both of the equations we've been given. So starting with equation 1, I'm going to rewrite it here. We have y equals x plus 4. So the point -2, 2 should fall on this line. And so what I'm going to do is plug in these x and y values and see if the left side and right side equal each other. So for y, I have +2. And for x, I have -2, and I have that +4. And we can see that -2 plus 4 is 2, so this does work out. Let's try it with equation 2. Y equals -1/2 times x plus 1. Again, I'm going to plug in my values. So -2. And so in this case, I have -1/2 times -2, which is just going to be 1. And 1 plus 1 does equal 2, so this does work out, and we know that point P, for part 1, the answer is point P lies at x equals -2, y equals 2. Okay, so let's move on to part 2. Part 2 is asking us to find the length of segment AB if the straight line x equals 1 intersects lines 1 and 2 at points A and B respectively. So let's draw in what this straight line x equals 1 is that's intersecting. That's going to be right here. Vertical line at x equals 1. So we can see that our intersection points are here and here. I'm going to call this top one A and this bottom one B. And so again, we could look at our graph to try to figure out where these points lie and what the coordinates are to figure out this problem. But it might be a little bit hard to see exactly where the points are. So in this case, I'm going to figure this out algebraically from the equations we've been given. So what we want to know is what are the y values for each equation when x is equal to 1. And that's going to give us points, the coordinates of points A and B. So starting with equation 1, I have y equals x plus 4. I'm going to plug in 1 for x. So I have y equals 1 plus 4. And this gives me y equals 5. So equation 1 is this one here going through point A. So this means that when x equals 1, y equals 5. So point A is at 1, 5. So for our second equation, we have y equals -1/2 x plus 1. And again, I'm going to plug in x equals 1 for this. Here, and Negative 1/2 times 1 is just negative 1/2. And then when I add 1 to a negative 1/2, I have a positive 1/2. So this means that point B down here is that x equals 1, y equals positive 1/2. And we can see that it does look like that, but maybe we couldn't tell that it was exactly 1/2 from the graph. So, okay, we have our coordinates for point A and B. The question's asking for the length of the segment between A and B. So, since this is a vertical line, what we can do is subtract our y values to figure out the distance between them. So, I'm going to take 5 and subtract 1/2. And this gives me 4.5. We've been told in our question that each unit on the graph is 1 centimeter, so this is going to be 4.5 centimeters. And that's the answer to part 2 of question 3.